Hello, this is Dr. David Kordowitz and welcome to Solidworks. Today we're going to be looking at some intermediate and advanced sketching skills as well as how to use relations to further enhance your sketching abilities and your definition of your sketches. Let's begin. So today we're going to start with a sketch which is on the front plane, and we are going to use some of the sketching tools to make this sketch complete. First of all, I'm going to review dimensioning the sketch really quickly so that you can better understand how things work together. So we're going to hit the Smart Dimension, and then we're going to start from the bottom and click on the first line, and we're going to set a dimension. So let's say we say 15. So I'm going to set that to 15 millimeters. Now we go to the next line, and we continue. I'm going to say this is 30. And then we're going to say that now we're going to do a dimension here, and we're going to say that this is going to be 10. Now we get to an interesting dimension. So if I go ahead and I click on this diagonal line here, it's going to give me a few different options. First, I can go diagonally like this, and doing that will give me the length of the line. However, that length is at the angle it's at. So what that means is if you see the arrow that is parallel to the line, that's giving you the length of the line in whatever direction it's in. Now if you pull the mouse down a little bit, you're going to notice that all of a sudden I have a vertical bar here, and that's giving me the length vertically of this piece. So if I want to measure it based on height, I can do it this way, or I can measure the entire length, or I can tip up, and now I've got vertical bars and I'm measuring the horizontal length of this. So all three of those values are going to be different, and sometimes it's very difficult to tell which one of them you're measuring. My recommendation to you is to be very sensitive to what you're measuring, because later on when we start adjusting angles and using relations, you'll notice that things don't exactly work out right if you have the wrong dimensions. So let's take, for example, that I'm going to measure here on the direction of travel, and we're going to say that this is, say, 35. So you set that, and what that's going to do is now you see everything is fully defined. Now another option would be to set the angle between, say, this line here and the little piece of the arrow down here. To do that, I'm going to go ahead and delete the dimension that we have here already. So I'm just going to delete that one. And now we're going to do the angle by simply clicking on the line and then clicking on the other line in the angle. So we've made the angle. And now if you notice, our measurement is in degrees. So I can then set that to say 45 degrees. And we know what our length and height have to be due to trigonometry. Now if you notice, I've drawn half an arrow here. What if I want the other half? So this is a trick that's going to save you time. We're going to use the Mirror Entities tool. So the Mirror Entities tool is going to allow us to mirror these lines across some central axis. Conveniently, I have this construction line here right in the middle that I'm going to be using as my mirror axis. So the first thing I do is hit the Mirror Entities button. And then we're going to choose what we want mirrored. So we want basically the whole arrow mirrored. Now note, we do not select the center line, because if we did, that center line would get mirrored onto itself and it can do different things. Now if you notice over here in the Property Manager, we have copy checked. What that means is that it's going to make a new copy of those lines when it mirrors it. If you uncheck copy, what's going to happen is it's going to move your lines into the mirror image, so you're only going to still have half an arrow on the other side. The last thing we have to do is click in the Mirror About box, and this is where we define the line we're mirroring around. So now I'm just going to click on my dotted construction line. So when I do this, if you notice, I now have a yellow outline here of a copy of the arrow. I agree that that's correct, so I'm going to click the OK button, the green checkbox, and now I have a complete arrow. So this is a way of saving yourself time when you have geometries that are symmetric. So you can do symmetric geometries by only doing half and then mirroring either way across some central axis. Now let's say I want to do something that is repeated. So let's say I take this and I want to make a pattern that has 4 of these rotated at 45 degrees. That might be something you want to do. So what we can do now is, if you go over here, we have a linear sketch pattern, but if we hold down, we have a circular sketch pattern. So we're going to choose the circular sketch pattern. And the first thing we have to choose here is where we're sketching, where we're rotating about. So I'm going to pick the point at the head of the arrow. So if I do that, that should define our rotation location. So now with the next thing we have to do is we have to select our entities to pattern, which is basically going to be the arrow. So I click on that, and if you notice, I now have a lit up set of 4 arrows around. Now, a few things to note here are, if we look at it, we have our equal spacing check. That equal spacing means they're actually going to all be at the same angle. We're going to have the dimension radius, so that's going to give us the radius so that everything is defined. We also have dimension angular spacing. That's if you want to tell it, how far apart you want them, so if you want to define them differently. So we basically have both of those set down here. We can set our instance count. So right now we're at 4. If I went down to 3, I'd only have 3 arrows, and it will automatically respace those as necessary. Below that is just the calculated numbers that it's using. If we set those manually, it will override the defaults. But let's go back to 4. Now, if I click the checkbox here, we're going to have our 4 arrows put together, and we end up with something that looks kind of like a cross. But you can see that it's actually constructed of 4 individual arrows. So that's a really useful tool if, say, you have something that you want to do around a circle. So, for example, if you're designing a wheel and you want to put the holes for the lug nuts, you can use a rotational pattern or circular pattern to define those at regular intervals. Now we have the equivalent for a linear pattern, so what we can do is click linear sketch pattern. And for linear sketch pattern, it has an x-axis and a y-axis. So if we say pick one of these arrows, and then we can set our x spacing here. So right now it's at 10 millimeters. Let's say we put it at 100. And so what it's going to do is it's going to pattern it every 100 millimeters. Right now we have it set to 2 on the x. We can go to 3, 4, whatever you want to do, however many you need. You can also then go in the y-axis. All you need to do to activate the y-axis is, instead of saying that you need 1, just increase that to 2. Like this. If you try to go below 1, you're going to get an error, as you've seen. Now, we can also set that the distance here be, say, 100. The other thing you can do is you can use these angle definitions. So we can say that the y-axis is going to just be 45 degrees, for example. And what it'll do is it'll tilt it at 45 degrees. So this is actually a really useful tool in terms of being able to make more quicker. So the idea here is, if you're trying to do something that's a pattern that has repetition, so for example, you want to make a chessboard, you can use linear patterns to define the different blocks. Linear patterns and circular patterns are really truly your friends for getting things set up. Okay, let's take another look here at a few things that we've been working on. So now we have this design here, and we can do some interesting dimensioning if we want to. So if we take the smart dimension, we can go from, say, the line here, this outside line, to the line on the other side, and we can find out that this is 110 millimeters. Now, it's gonna be driven in this case because the arrow itself is fully defined, and our drawing currently, if you look at the information bar, is fully defined. Therefore, there is no additional information we can add. So that should show you this is one way to develop things very, very quickly. Now we're going to move on and talk about how to do a little more dimensioning with doing things that are concentric and things that are like that just in a second here. Let me load another image up so that we can continue on. So this drawing has 4 circles on it. 2 of them are inside of each other, and 2 of them are outside. So what we're going to look at here is how to do dimensioning on this type of image. So the first thing I'm going to do is dimension this inner circle. And let's say that it is going to have a diameter of 20 millimeters. Now, usually the first dimension that you do, you're going to see that quick zoom in thing and it's going to zoom back out. That's because it has to set the screen parameters because we're defining that as 20 millimeters. Now, an important thing to notice here is that it says phi 20 millimeters down here in the dimension. The phi means you're looking at the diameter. If you see an R, that's a radius. So always be sure if you're seeing a diameter or a radius. Now, an option that we have here is we can dimension the circles off of each other. So let's say they're going to be 10 millimeters in this band around the circles. So I can click on the innermost circle and then come out and click on the outermost circle. And what it's going to do is it's going to give me a distance between the circles. So we can say 10 millimeters. And when we do that, they become fully defined. So this is one way of doing it. Or an equivalent would be to click on the circle on the outside and set it to 30 millimeters, or 40 millimeters, sorry, 40 millimeters. So if we set that, we get the exact same result as if we did it as the internals. Sometimes one is better than the other, depending on how you're designing things. If you're designing, say, a tire, you probably want to know the wall thickness of the tire, where the outer radius may matter, but you need to know how large the cut of the hole in the center is. You can use the offset method to do it that way. Now, an important thing to notice when you're relating circles to things, when you're measuring dimensions of circles to things, the default, if I click on a circle and then I click on, say, another circle like this, and I click on, say, the outer circle here, it's going to go center to center. But that isn't always what you want to do. Sometimes you want to look at edge to edge. So for example, let's say I put a square in here and I want to know how far the edge of this circle right here is from the top of the square. We can measure from the center, as we said before, or we can measure to the edge. To do this, we're going to use the Shift key. So we're going to hold the Shift key and we're going to click on the box, and then we're going to drag up to the circle, and we're going to find that we get now a dimension of 9.22. So let's say we change that to 10. What that's going to do is that's going to give you the distance from the closest point in that circle to the line we've just drawn as the top of this box. That can be incredibly useful when you're trying to determine clearances and things like that. So now, how can we dimension things to get more definition and more power out of our dimensions? Well, the most useful way to do this is using relations. Relations allow us to determine how two entities or boxes are related to each other. So let's go through first and set all of our dimensions here. So I'm going to set this to 25 and this to, let's say 15 since it's already there. And then we'll set this box to some sort of dimensions. So say 30 and 30. And so we get a square. All right, so now things really aren't attached to each other. So I've got all of these dimensions here and everything is sort of in its own space, but we don't really know how things are interrelated. So to use relations, we can't be in smart dimension. We have to be out normal. But the first thing we do is hold the control key and click on the entities that we're interested in. So let's say I want to look at this outer circle and this circle over here. If I control click on those, I'm given a few options. The first one is co-radial. What co-radial means is it's the same circle. It has the same radius. They share radii. So a co-radial circle is going to be identical to another co-radial circle. So probably not what we want to do here. The next one is tangent, which is what we do want to do. And tangent means that they are touching at exactly one point. So if I click on the tangent button, you'll notice that it jumps up. And now I get this little green flag next to my circles. And that's saying that they touch at exactly one point. The next one is what we call concentric. Concentric means that the two circles have the same center point. So for example, the two circles here, the 20 millimeter and the 40 millimeter circles, those have the same center point, thus they are concentric. The next one is equal, and what equal means is they have the same diameter. So two equal circles will have the same diameter. They're not necessarily in the same place. The next one down is fix. Fix is really the sort of catch-all, nothing will work type thing. A fix relation will basically say, I like where it's at now. I don't care if it's not mathematically correct, but I'm going to keep it. And the last one down is equal curve length. That's got more to do with when you're doing multiple curves that are not complete circles. But at this point, we're set on tangent, so life is good. However, if you notice, the line around the circle is still blue. So if we're curious why, we can just grab the circle and move it. And you'll notice that it rolls around the circle. I can't pull it away. I can't do anything. But it rolls around the circle, touching the circle. So what we need to do is we need to define how exactly this circle is related to the coordinate system it's in and where does it land. So let's take an example of, let's control click on the center point of the origin and the center point of this circle. Now I have a few other options. I have horizontal. If I click horizontal, that's going to make the center point horizontal to the origin, so they're going to go along the x-axis. I have vertical, which is going to put it along the y-axis. I have fix, which again is the catch-all to make sure that everything stays the way it is. Fix is not a really good way to do things. And the last one is merge. And what merge will do is it will attempt to make those 2 points the same. So it's going to attempt to grab those 2 points and make them into the same point. Now that isn't really what we want to do here, but let's say I go with horizontal. So if I click horizontal, it's going to roll this ball around to be horizontal like that. And then if you notice, it turned black, so it's fully defined. So let's take a look, for example, now at the icons that we're seeing. So we have here this straight horizontal line that's telling me that those are horizontal to each other. If we come over here, we have our tangent. The one over here is our coincident point. What that's saying is that the center of the circle is at the origin. We have on our square, we have some verticals. So we have 2 lines that are vertical and we have 2 lines that are horizontal. Now, what we could do here is, let's get rid of these. We could get rid of them by simply clicking on them. They'll turn blue, and just press the delete key on your computer. So let's say we delete these 2. Now we can say, dimension these by control click on this line and control click on this line. Well, 2 lines have a few different relations they can have. They can be horizontal, they can be vertical, they can be collinear. What collinear means is they fall on the same line. This is one of the more useful ones when you're doing things that have discontinuity. So if you're doing a circle or a radius that continues on from another radius, those become collinear. We have perpendicular, which in this case is what we want because they are at 90 degrees from each other. We have parallel, which means they are parallel to each other. They run alongside each other. It's a weaker relation than horizontal or vertical because it doesn't define the direction. We then have equal, which means basically make the lines the same. And we have fix, which again is our catch-all. So let's go ahead and hit perpendicular. And by doing that, we've now got a perpendicular logo here. So if I want to make this fully defined, I can simply, I need to know where this is relative to the origin, so I can go and dimension, say that this goes to the origin, and we can say that's 15 or something. And then we can say, okay, so where do we want this? So if we go on this line here and we scoot along it, you'll notice that I have a little yellow box that shows up. If I press the control key and click on that little box, and then let's say click on the origin, I can say horizontal, for example. And if I do that, now it's guaranteed to be the midpoint of this line to be horizontal with the origin. Now, the reason that we're not yet fully defined here with this particular box is because we've got vertical, we've got horizontal, but what we don't have quite yet is the relation between this perpendicular line here. We don't know that one of these lines is horizontal and one is vertical. So we have 2 choices. We can either go ahead and take this and one that we know is vertical and make those perpendicular. And if we do that, now we're defined. The other option would be to define one of those as horizontal or vertical. So now let's take an example. If we say the center of this point here to the center of this line, we can do that, and we can say, for example, coincident, which means turn them into the same point. So if we click that, we get a slight over definition, and the reason we get that is because of this 10 here. And so you click on that 10, we can delete that, and everything falls into place. Now I would go through and trim this to make it into a single entity. So we can trim, and we can do trim to closest. And so let's say I trim this line out, yes. Trim this line out, and then we'll trim this line out, and this line. Now all of a sudden we're back to not being fully defined, and the reason being is because we've deleted some of our dimensions, whether intentionally or unintentionally. So let's add a few relations to fix this. So if I click on this line here, control click on that, and control click on this line out here, we want those to be collinear because they fall on the same line even though there's a discontinuity. We then want to take the center point of the circle and one of these lines and set them to be coincident. By doing that, we guarantee that that dot is going to fall somewhere on that line. We now want to say, okay, how far is that dot going to be from the line? So let's dimension that out. So we can take this point here, and we can take this point here, measure as 12.5. It's going to say that it's driven, which is good. That means we're in the right place. So now what we need to do is we need to know, okay, well, you know, how far is this little line here? So let's take that. It's 2.5. So we're going to leave that as 2.5. And we're going to set this one to be the same 2.5. It's going to be driven because we don't know, because we do know sort of the dimensions that it's going to have. And we do know where it's going to fall. We know that this down here is 30, but we don't have that center point anymore. So one thing we can do is we can add a construction line or a center line and connect the dots here. So I can take that, connect the dot down there, and now I can just align based on the new center line that we have here, there to there, and align those to be horizontal. And in doing that, we should now have that alignment set, and we just have to define the distance here. So 0.77, we do that, that gives us our height. We are now back to fully defined. Now this process of figuring out what relations and definitions you need to make your drawing fully defined, this is a little more art than science. So it's one of those things that you're just going to have to get used to working on, and you're going to begin to see it. It's not something that really can be taught, but it's rather something, the more you work on it, the better feel you're going to get for it. Now, when things are over-defined and things like that, you can use the colors of the markers to tell what is what. Yellow is that it's over-defined, and red means it's impossible. So I hope this helps a little bit with understanding how to draw a little more advanced, but also it helps you understand how relations work and how to put things together. I'd like to thank you for your time today, and good luck applying this to future drawings. See you next time.